Right, let's get into some nominal and effective.
Right, let's get into some nominal and effective interest rates. Okay, so let's go for it here. So this all looks much more complicated than it is. This whole things, blah blah blah, and this long formula and effectives and compoundings and that. Here's the basis that we need. Let's say that you're given some sort of interest rate, and often talk interest rates end up being something like, our interest rate is 11% and it's compounded monthly, and we had that idea of over 12. And then, somebody else says, okay, but I can offer you an interest rate, and my interest rate is, 11.5%, but my one's compounded semi-annually, twice a year. And then, okay, which one's now it's hard to compare. You want to compare apples and apples. So you want to go, okay, well, what's our effective interest rate? So we have this idea of I effective. If we were to just compound annually, what do all these equate to? So how do we turn things into some sort of effective interest rate? So let's have a look here, and I'm going to remove all of these, and let's make sense of this equation. You are not given this formula in the formula sheet, so let's find a way that we can remember how to do this as well. So our formula here says 1 plus I effective is 1 plus I normative n to the n. Now, a formula that we're quite comfortable with by now is A equals P 1 plus I to the n. Right? You use that quite often. If I invested, let's say 10 Rand, you go 10 Rand, and I said, let's invest 10 Rand at an interest rate of, let's make it different, so 15% per annum compounded monthly. So I'm going to write 1 over 12 to show that monthly. You would go, okay, well, A equals, 10, 1 plus our interest rate, 0.15 over 12. I'm going to tell you we're going to invest this for 1 year. So then you go, oh, well, 1 year is 12 months. You put a 12 here. Okay, now the bit of the equation that I want you to focus on here, your formula is, forget how much you invested. That doesn't matter. What we're interested in is, what's the interest rate and what's your compounding period? So 12. So if you look at that formula there, that's just the right-hand side of that formula that you're not given. So 1 plus that. Now, let's say that you wanted to see what this was as an effective interest rate. You'd have 1 plus I effective. And there's your formula. Can you see it? 15%, 12, 12. If you wanted to convert this 15% compounded monthly to an interest rate that were compounded quarterly, the left-hand side of your equation would be 1 plus I over 4, because it's quarterly, to the 4. If you wanted to convert this monthly interest rate to, say, semi-annually, then you go over 2, because it's semi-annually, to the 2. If you wanted to do it as an effective annual interest rate, well, in some ways you're thinking of over 1 to the 1. But now that and this are the same thing. And you see that if you just, I over 1 is just 1, and anything to the power 1 is itself. So this is just, well, if we didn't write our I funny up there, it would just be 1 plus I. But the key bit that I want to kind of hone in on is, you keep on writing 1 plus I over whatever that thing is into the n. So if it was monthly, 12, 12. If it was quarterly, 4, 4. And that's what we've been writing for quite a while. Okay, ready to hit a few examples. I know that I am, so let us go for it. Let's convert 15% per annum compounded monthly to an effective annual rate. So I'm going to jump us through this one and say, now it's compounded monthly, so I'm just going to focus on the right-hand side. We've written this part of the equation a few times. 1 plus I over 12. Now it's like we're investing it for 1 year, so that's the right-hand side of our equation. We're going to an effective annual rate, so we just apply right here 1 plus I. So there's our equation. We solve for I. Doesn't take too much. Subtract 1 from each side. And let's see. For I, what do you get? Okay, well, that's what you get. I know that I'm going to need a calculator to help me on this one. So, calculator up here. And we've got 1 plus 0,15 over 12 to the something or other. 12, right? Because those match up, the 12 and the 12. And we subtracted 1 from each side. 0,16075, 0,16075 something or other. Times that by 100 to get it as a percentage. Times 100, 16,08. 16,08%. In other words, and really am thinking through these first ones just to try to make sense of it a bit more. 15% per annum compounded monthly means that it's compounded every month. So to get the equivalent that would be compounded only every year would be 16,8%. And we went through some examples way above, comparing different compounding rates, and we've done one of those. So let's go into the next one. Convert an effective annual interest rate of 14.2% to a nominal annual interest rate compounded monthly. So let's do the right-hand side like we did before. 1 plus, this 1 over 12, we don't know what this I is. So I'm just going to put an I here. But the effective annual interest rate is 14,2. So the left-hand side of our equation is kind of the one we're given now, 0,142. Just one thing to solve. So, let's just move that out the way. Go for it. Solve, and what do you get? Because there are now a few more tricky steps in between to do this, and I'll show you each of the steps. You've got them there for reference. So go for it, solve. Okay, so you've solved, and let's see if we get anything similar. Calculator, calcu. Don't worry. The mean machine, the what? Oh, so many lovely names for it. So let's pop it up here. So for this to solve, we want to kind of get to that I. So that's where we're trying to get to. So the first thing we need to do is take the 12th root of each side. And then we'll have that bracket. So if we've taken the 12th root, this is what is going to be on our calculator. After taking the 12th root, the brackets aren't really doing too much anymore. We're going to need to subtract 1. Then in our next step, that will just leave us with I over 12. Finally, we'll need to multiply by 12. And the left-hand side will be whatever's sitting in the calculator. So to start with, we've got 1 plus 0,142. That's on the left-hand side. Then we said the first thing we need to do is take the 12th root on each side. So shift that one, 12th of that, whatever that was, is that. Then we've got this on the right-hand side, that thing. So we need to subtract 1. So let's subtract 1 equals, okay, now what we've got that, so we need to multiply that by 12, and we get 0,133 blah, blah, blah. Yeah, it is blah, 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 right? And, times by 100 to get it as a percentage, 13,35. I'm just going to go for 2 decimal places by default. That is what I. And let's just check, does that make sense? It should be lower than this number. Because if we get 14,2% every year, if we're compounding more often, we'd need a smaller percentage. Okay, I don't have a good sense of how much smaller that should be, but I know it should be smaller. Next one. Okay, next one it is, and let's convert a nominal interest rate of 14% per annum compounded monthly to an equivalent nominal annual interest rate compounded quarterly. So let's keep our rhythm and our routine as we were doing the previous one. So I'm just moving that out the way. So on the right-hand side is kind of this 1 plus whatever. Now we're given 14 monthly. So 14% monthly. And just in terms of how we're feeling, is this, I don't know, is this a useful strategy? I haven't seen any other strategies, so that's a difficult, unfair question to ask or to answer. But just, is this starting to feel like it's embedded now? This 1 plus I over 12 to the 12, kind of what you've been doing in the, A equals P, but now we're just doing it that way. So just a smiley face or something or other. Okay, well, whatever something or other you put in. Okay, but now what we need to convert this to is an equivalent nominal annualized compounded quarterly. So now on the left-hand side, we're going to do the same thing. 1 plus I over 4 to the 4. But now this time we don't know what I is. So now we've got something to solve. So go for it, solve. Of course, the question is... Whoopsie. The question is, what machine are you going to use? That wasn't actually going to be the question, but I don't know. I keep pressing the wrong buttons. How are we going to be back there? Okay, well, there we are. Let us solve this. What I really want is why I calculate. That's because I didn't press the heart button. You see? All better now. Okay, so to solve this one, we're trying to get into this I over here. So to make our way there, the right-hand side, let's just pop that into our calculators along. We've got 1 plus 0,14 loop over 12 loop. Lots of loops, eh? Well, it wasn't quite sure how to spell that. Loop sounds like loop. Okay, to the power of 12. Okay, so that's that thing on the right-hand side. So first thing we're going to do is let's take the fourth root, because we kind of need to work our way into I. So let's take the fourth root of each side. And we've got 1 plus I to the 4 equals whatever our calculator tells us now. Shift that 4 to ons equals that number. Now you could write it down if you wanted to. Doesn't really matter because we know it's being stored in the calculator. Okay, then we need to subtract 1 from each side, and our equation at this stage will be that. So 0,035 blah 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 minus 1 equals, okay, last step that we need to do is multiply by 4, and we will have our I. So times 4 equals 0,14161416 something or other. And I'm not rounding off till right at the end and saying, okay, so our interest rate is 14,16. 14,16 as a percentage. Now, I should finish this off and say compounded quarterly, but it's kind of a given from the question, we know. So, I don't know, somewhere behind me, there we go, compounded quarterly. Wrote it so entirely you couldn't tell anyway, hey? Okay, but, it's the context from the question is there. So, in other words, if we invest something at 14% per annum compounded monthly, that's the same as investing at 14,16 compounded quarterly. Again, that's a bit bigger, so that makes sense. Before we head into our last one, and I know we're heading along, but we're having too much fun here. Let's go back to this first one and just kind of check. Now that we've gone through a few examples, let's see what this means. 15% monthly. So I'm going to just put this here. 15% monthly, we're saying is the same as 16,08% annually. Now let's actually just test. Like we said that's our answer. Let's check, does it even make any vague sense? Goodbye, calculate. Gone. Okay. So if we let's invest 100 Rand. If we invested 100 Rand for 1 year at 16.08% compounded annually, 1 year later, how much money would we have? Okay, well, we've invested 100 Rand, we're getting 16.0%, so we must be earning 16 Rand 8 cents. So we must come out with 116 Rand and 8 cents. If you really wanted to put into an equation, we could go A equals, I think I need to move out the way. Maybe I should be in the middle, like between the two. That works nicely. Don't you think that works well? Some brutal honesty. Okay, so invested 100 Rand at 1 plus 0,1608 to the 1 year would give us that number up there. Now, what we're saying is that That's going to be the same if we invested it at 15% per annum compounded monthly. So if we invested 100 Rand at 15% per annum compounded monthly, how much money are we going to have at the end of that year? But more importantly, can you write down the equation to solve that? Okay, well, A equals P 100, 1 plus 15% compounded monthly for 12 months, right? So that one there. So that's what we're saying if we invest over 100 for 1 year, so for 12 months. So we put that into our calculator. There we go, 100, 1 plus 0.15 over 12 to the power of 12, 116,08. 116,08. Okay, so it did actually work out. If we invested 16.0% compounded annually or 15% compounded monthly, we'll get the same amount out. Okay, cool. That was interesting enough to see. And we're into our last example. Let's just like to build up here. So what do you reckon? Let's get into this. Let's sound off. Let's also maybe some other sound effects. Do you think, what sound effects can you suggest? Come on, we need some new ones for the next video. Okay, well, Joyce borrows 500 Rand from a friend and agrees to pay back 600 Rand 1 month later. Determine the monthly interest rate. Okay, so this is an interesting one to play with here. Now, I need actually kind of take a pause and remove that. And just some ideas. I mean, do you have some ideas of how to solve this? I might have got kind of two distinct ways of doing this. But there's one way that I prefer actually to do this. So let's see. Ideas on how you're going to do this. Now, I think I'm always impressed by how you try and write down your ideas, because sometimes it's easier to kind of think and show, and you want to be like, well, I want to do this and write that formula. So yes, complete well done for like really kind of trying to express yourself. So Joyce borrows 500 and 600. So I just think, well, we know our formula, right? A equals P 1 plus I to the n. So if we just substitute our values in here, we've kind of invested, or Joyce has Chomi invested 500 Rand in Joyce, and she's getting 600 Rand out later. It's kind of like 500 Rand was put in and 600 comes out. At 1 plus, we don't know our interest rate, but we know that it's happening monthly for 1 month. So there's another way of doing it that I'm not going to go through in this video, where you do it, over an annual interest rate. But I like this idea, because we've got 500 Rand invested, we get 600 out, we've gone for an interest rate that we don't know. This is already a monthly interest rate, I over 12. So if we do that, we just need to solve for I. Now, we've solved a few things. So my question, quite simply to you, is, what do you get for I? Okay, so let's have a look. Let's solve this. So I need, there's one of these somewhere, right? And we've got, it's like a double play. 600, so let's solve this. 600 divided by 500. So that's the first thing that I'm going to do, is divide both sides by 500. Then I've got 1 plus I over that to the 1. The 1's not doing much, so I'm just going to subtract 1 next. Minus 1 equals a fifth. That's I over 12, so I just need to times that by 12. 12 over 5. Okay, so I equals 12 over 5, but I still need to multiply by 100 times 100 to get it as a percentage. And my goodness, 240% is massive. Okay, so 240% though, that is the interest rate. So that interest rate, remember, this is a monthly interest rate, which I'm shorthand writing as a 12. But we should really say per annum compounded monthly. Now, again, we know from the question that's what we're working out. Now, part 2 of the question, let's put it somewhere. That side, right? Okay, so part 2 says determine the effective annual interest rate charged by the friend. So that's the monthly interest rate, 240%. Now, when we work out the effective interest rate, so kind of the annual one, should that be a higher percentage or a lower percentage? That's just, maybe you've got an idea, so then you can just block your ears for my trying to help you in this question. And that is, if it's 240% and that's compounded every month, if we turn that into something that's only compounded every year, but it should be the equivalent, should that effective interest rate be higher or lower than 240%? Well, let's put it in and see. 1 plus I effective. Now, I'm already doing that, but then I'm going against that beautiful idea that we had earlier, which was put this thing on the right that we know, 1 plus, over 12 to the 12. We know our monthly rate there. So let's put that in and say, well, we know it's 240%. What's strange about that is that's the number 2.4, 240%. And what we're trying to find out is the effective interest rate. Now, if you just write 1 plus I, that's fine. We don't need to write I effective because we know that's what we're working out. Okay, so we just need to subtract 1 from each side. So I equals, and let's see what we get. And somewhere for the last time, and we've got that calculator. Do you think if I move you, I never move this calculator enough, do I? We'll just let it get in the way. So we've got 1 plus fraction 2.4 over 12 to the power of 12. I'm about to ask you what you get, so go for it. What do you get? Okay, so you've put something down. Now, remember that we don't have that as a percentage yet. So we're still going to have to multiply that by 100. So, equals 7.9. 7.9, blah, blah, blah. But, as a percentage, we still have to multiply that by 100. 791,61. I'm flabbergasted. This is a huge percentage that is for that 500. Joyce's friend has done pretty well here, I think. It feels like, you just got 100 rand, but you got a phenomenally high. I mean, can you imagine that you borrowed 500 rand and Joyce only paid it back a year later? I can't imagine how much she'd be paying back. So watch out for Joyce's friend, and let's put that back over there. And I think let's, head back into our music.